All right, here we go. When we look at this picture here, you guys can see that it's not consistent throughout. There's different parts. There's different pieces to it. Okay, so you definitely know it's not an element, because an element is anything on your periodic table, so it's a single thing. And a compound too, you won't be able to see different parts to it. So now we know that it's a mixture. So it's either homogeneous or heterogeneous, and homo means that it's going to be the same throughout. Okay, so your answer choice here has to be D. Okay. All right. Next one. This says radium-226 decays into radon-222. What type of radioactivity is taking place? Okay, so radium, what we know is this. We go to our periodic table, we know radium. Where's radium? Where's radium? Okay, radium is right over here. And we know that, here's the key. Because it's radium, it's going to have 88 protons. Radium has 88 protons. So we're going to say this is Ra, and I'm going to put an 88 here, and I'm going to put 226 here. Okay, this is going to break down into radon. So I need to find radon. Radon is here, okay, and radon is 86. So this is going to break down into Rn 86, and it says that this is 222. Okay, so what we have to do over here, we have to find out which piece is going to complete this. So whatever these two totals are, I have to have the same thing over here. Okay, so the difference between 226 and 222 is 4, right? Because 222 plus 4 is going to give you 226. 88 and 86, I need to have a 2 here. Well, which element has, and this is the number of protons, right? Has 2 protons. That's helium. So this is helium, and we know that this is an alpha particle, right? So this is alpha. All right, next one. Number 30. All right, it says a balloon is filled with 0.02 moles of a gas that has a volume of 0.48 liters. Some of the gas is removed from the balloon, giving a new balloon volume of, what is that, 0.24? Alright, maybe that's better visually. So it says how many moles of gas are left in the balloon, assuming that the pressure and temperature has been held constant. So let me look. I thought I had a chart with me. Give me a second. Alright, so if we're looking at this chart right here, okay, this is going to says initial volume and initial moles, final volume, final moles, okay? So our formula that we want to use is V1 over N1 equals V2 over N2. So we're going to say V1 over N1 equals V2 over N2. Alright, so they said that a balloon is filled with 0.2 moles of a gas and it has a volume of 0.48 liters, okay? So that's going to be my V1 N1, okay? So this is going to be 0.48 liters, and this is over 0.02 moles. Okay, and over here it says some of the gas is removed, and so this is going to end up being 0.24 liters over X. We don't know how many moles that is, right? Alright, so in order to solve this, you guys can cross multiply whatever you want to do. If you cross multiply, we would say this is going to be 0.02 times 0.24, and this is going to equal X times 0.48 liters, right? Oh, you can see it. Okay. So we're going to say 0.024. Oh, that's wrong. 0.02 times 0.24 equals, and then, yeah, it's a bad calculator to use. I need to divide both sides by 0.48. Okay. Alright, so I have 0.02 times 0.24 and divided by 0.48. And so my answer is 0.01, okay? And so if you look at all these, and remember, we got to worry about significant figures, right? Each one of these only has, this has one sig fig, right? And this one has 2. My answer can only have one significant figure, so my answer has to be gridded in here as 0. Oh, I messed it up. So it's going to be 0. Imagine that's a big point. 0.01. So you guys can figure out how to grid that. Okay? All right. Great. 31. It says potential energy is a form of energy that this is not true because you can convert it to kinetic due to random movement of particles. When it's potential energy, it's the energy to do work. It's not actually doing anything, right? And so this says release due to physical position of chemical. What? I don't even know what that means. This is going to be stored energy, okay? Any of your potential energy is always going to be stored energy, okay? So your answer choice here is B. Excuse me. If it was kinetic energy, is probably the one that would have been released, I guess. I don't know. I'm not thinking very good right now. All right. Which of the following is an oxidation reduction reaction? Well, remember, we said oxidation reduction is going to be with anything, like double replacement reactions are the only ones that aren't oxidation reduction, okay? So if I look at this, this is a double replacement because this and this come together and this, right? So also we have the same thing here, double replacement, double replacement. However, in this case, we have an element, okay? It doesn't matter how many 2's, I could put 50 behind this. This is something that's by itself, okay? So the oxidation number here for this one is 0, and over here the oxidation number is +1, okay? So in this case, anytime you see an element that's by itself, O2, H2, whatever it is, and it's now combined with something else over on the product side, that's going to be your oxidation reduction reaction, okay? All right, 33, it says, select the correct formula for carbon disulfide. For carbon is a nonmetal, sulfur, so sulfide being replaced for the sulfur part of it, is also a nonmetal, and there's 2 of them, so this is going to be D, CS2. 34. Using information provided in the table, determine the average atomic mass of the unknown element. All right, so this one, all we're going to do is we're going to convert your percent abundance. We're going to convert this to the decimal, and then we're going to multiply it by the mass there, okay? So remember, anytime we're going to do this, we're going to divide all of these by 100, okay? And so that's going to convert it to its decimal form, all right? So this is going to be 0.9933 times 14 plus, what is this going to be? 0.0067 times 15 plus 0.00001 times 16. Okay. But if you're looking at, well, what's important to this is know that 99.3% of this is going to be 14, right? So if we were to guess, your answer would probably be, you could count out that it's 16 because there's only a small percentage of it 16. So it's not going to be 16. This is a really big number. So now you got to look that it's got to probably be between 14 and 15. All right. So let's do the math. So this is 0.9933 times 14. And so this is already getting you to 13.9. So if I add into this, so I'm going to add to this plus 0.0067 times 15 plus 0.00001 times 16, and we get a total of 14. So your answer choice is A. Alright, number 35. Alright, so this says, while creating a piece of artwork, a student becomes curious about the ink he is using to create it. He wants to know if it's a pure substance or a mixture. If the ink appears to be uniform throughout, but separates when chromatography experiments is performed on it, leaving marks of different colors along the paper. While his observations, how would you classify it? So basically, if we can separate things out of it, it can't be a pure substance, okay? It has to be a mixture of substances. If nothing separated out, then you could say it was a pure substance. Now, so we can cross out element and we can cross out compound. So now we have to decide, is it a heterogeneous mixture or is it a solution? Well, here the student says that uniform throughout, right? Well, that automatically tells me that it cannot be heterogeneous, so your answer choice here has to be D. Alright, 36, it says, we have the following reaction here. It says, sorry, my throat's dry. Calculate the heat of the reaction in the formula. So, let's see. I'm going to tell you to do this one. you know what? I don't even know if we talked about this. Okay, that's okay. So this is my final reaction, okay? And if you notice here, we have, I need to have 2 fluorines in the final reaction, right? Well, up here I only have 1. So I need to multiply this whole thing by 2, okay? Now, when I do that, I have to take this and I have to multiply the energy by 2 because I'm adding, you know, it's 2 moles of it, so I'm doing twice as much, okay? Down here, the problem is I have water on the reactant side, but over here I have water on the product side. So what I actually do is I need to flip this reaction. So this is going to be 2H2O, and this is going to yield 2 hydrogens and oxygen, okay? And so when I flip that, because going in this direction the reaction is exothermic, now I flipped it and I'm going the other way, this reaction is now endothermic, so this is 571.6, okay? So we're going to go in here and I'm going to multiply this and I'm going to say 2 times, what is this, negative 546.6, and I'm going to add to it plus 571.6. Alright, and so here I'm going to get a negative 521.6, alright? And so we have to go ahead and the interesting part about this, hold on a second, this is negative, because what, sorry, I need to show you this too, what happens here. Alright, so I got hydrogen over here, I've got, and this, since we multiplied this by 2, I have 2 hydrogens here, can't see that, I have 2 hydrogens here, I have 2 fluorines here, and I have 4 of these, right? So what happens is this and this cancel out, okay? Your oxygens are going to cancel out, so that what I find, and wait, there's oxygen there, my bad. Oh, this equation is gone. I'm really screwing this one up. Okay, so I'm going to bring down this H2. The only thing that canceled out, sorry, was my hydrogens, right? This O2 should still be here. So when you bring these down, you're going to get, you have 4 of those, you have your O2, you've got 2 waters, and you've got your 2 fluorines, okay? And so your answer, I don't know why this is giving me that it's not negative. Because the answer choice, I don't know, y'all have to look at it, but I got a negative 521, which I think the answer should be negative. So I think this should be negative, and this is, so when you grade that, you're going to say that this is 521.6. So that would be how you would grade that in. You put the negative there. All right. I don't know why they said it's positive. That doesn't make any sense to me. Whatever. I think the answer choice was wrong. I think this is right. All right. 37. Identify the configuration for the valence electrons for the alkali metals. Okay. All right. So when we talked about this, remember N is just, where did my periodic table go? Alright. N, these numbers out here, okay? And so they want to know this for the alkali metals. Remember, this is group 1. And so what they're saying is, and we know this, right? Everything here is an S1. Everything here is an S2. So N just means whatever this value is here. So it doesn't matter. If I said this sodium, I would say this is 3S1. If it was potassium, I'd say this is 4S1. Okay, these are all S1s. So your answer choice has to be C. Alright, 38. Rutherford designed an experiment in which he shot alpha particles into a gold foil. His observation did not match his predictions, which were based on plum pudding model. Instead, what did he actually observe during his experiment? Okay. We know that all of the alpha particles that went around the foil. We know that's not true because we know that some of the alpha particles actually went through the gold foil. So that's not true. All alpha particles went through the all the alpha particles went through the foil or were deflected at small angles. That one we know to be true. All alpha particles were bounced backwards. That's not true because we know some of them went through the gold foil, because remember, what were they hitting? They were hitting the nucleus. So he discovered that the nucleus was there, and so the nucleus is small in comparison to the size of the atom. All right. Most of the alpha particles went straight through the foil, undeflected, and few bounced backwards off the foil. Yes, this is the correct answer. In this one right here, it says all of them either went through or were deflected at small angles. We know that some of them actually bounced backwards. So your answer choice there for 38 should be D. All right, which is considered a physical change? Physical means that it can go back from state to state, okay? You know this color change of apple cores. Well, basically, you don't want to eat that apple at that point because it's brown and it tastes bad and it's kind of rotten. So this is going to be a chemical change, right? Adding iron and water and it forms rust. Well, rust is a chemical reaction because we can't go back the other way. And once you burn something, you really can't unburn it. So melting of ice, once we melt it, we can refreeze it. So this has to be a physical change, okay? Here we go. When aqueous solution of sodium hydroxide and copper 2 chloride are reacted, what substance will precipitate? So what we need to do is we need to go back to our solubility rules, which are on the back side of your periodic table. Okay, we get NaCl, so let's look at chlorine. Common exceptions. Is sodium in this exception? No. So this is not going to precipitate. And then we go to hydroxide. Here's my OH. It says compounds. This is insoluble unless it's with one of these. Ammonia, ammonium ion, the group 1, calcium, strontium, or barium. Copper is not one of those. So this will be my precipitate, D. All right, here we go, 41. You got 951 grams of water in a calorimeter changes temperature by 11.3 degrees Celsius when 1 gram of diesel is burned. What is the heat combustion? All right, so we know the specific heat, and it says, remember the combustion is an exothermic reaction. Temperature. What is the heat combustion of 1 gram of diesel? All right, so what we need to do, we need to use, where's my, all right, here we go, thermochemistry, okay? So we want to use the heat gained or lost. So we need the mass, we need the specific heat, and we need the change in temperature, all of which we have, right? All right, so we're going to say Q equals mass times Cp times my change in temperature. All right, so we know that the mass of the water was 950 grams. We know that the specific heat was 4.184 joules per gram degrees Celsius, and we know the temperature change was 11.3 degrees C. So all I need to do is multiply all of those. So I have 950 times 4.18 times 11.3. All right, so in this case we get 44,000. Is that right? Yeah, 44,872. Yeah, good. I got the right answer. Okay, so what they want, it says that they want to round it to the tenths place, not the, okay, that's fine, you understand tenths. And they want this in kilojoules, okay? Well, the answer is in joules. In order to get to kilojoules, we need to divide by 1,000, right? And what you need to understand is this. This value we said was, so we said this was 44,872, okay? So we divide this by 1,000. Okay, so I'm going to divide by 1,000. And this gives me 44.8723 kilojoules. They said that we're going to round this to the tenths place, and so in this case we're going to end up with 44.9. No, it's the hundredths place, because that's the hundredths. I don't know what they said, tenths place. See, this answer key is wrong, because if this is to the tenths place, this should be 44. This should be 8. 7. All right. This I don't know. This answer key says it says something else, but I don't think it's right. Anyway, so this is the energy. This is the energy that was absorbed by the water, right? So now, and that's a positive sign. So we need to flip the sign, because remember, whatever the water absorbed, when you burn this, they had to give off. So this is actually going to be now a negative value, okay? So we're going to put in here negative, and this is 44.87. Okay, good. 42. We're almost done. Applying what you know about ionization energy, choose the element that has the highest. Okay, so first of all, do you know what ionization energy? This is the energy to remove an electron, okay? Everything in group 1 and group 2 is going to have a lower ionization energy. So group 1, 2 is going to be lower ionization energy. I'm just going to put IE, okay? It's going to be lower because they want to lose electrons, okay? So if this is the energy to remove an electron, anybody in, let's say, group 7 and 8, they're going to have the highest ionization energy because they don't want to lose electrons, okay? They want to gain electrons. All right, so it says which one is going to have the highest. So if we're looking at this, we got fluorine, chlorine, and we've got potassium and vanadium. Well, these two are metals, and we know metals want to lose their electrons. So these two are going to be completely out, right? We want to look at the things that, so they have the highest energy, it's not going to want to lose electrons. So now we have the difference between fluorine and chlorine. Both are in the same group, so both are going to have, not going to want to lose electrons. But because fluorine is smaller, it's going to want to lose its electrons less because it has less of them. So this one is going to have the highest ionization energy because it does not want to lose its electrons. This one has more, and so it's a little bit more willing to give the electrons up. So your answer choice here is F. I mean, A. Okay. 43. Okay. You have a 21.7 gram sample of an unknown substance gains this energy when it's heated from about 20 degrees to about 204. What is the specific heat of the substance? So we're going to basically use the same equation that we used a little bit ago. All right, we're going to use this one here, and we're going to find specific heat. So they give you Q equals, so Q equals M times CP times delta T. All right, so in this case, let's see, where are we? Q, our energy. All right, so here I've got 18.55 joules. This equals my mass. I know my mass is 21.7 grams. We don't know specific heat, so I don't know CP, but I know my temperature. It went from, so we're going to say this is 204.5 minus 20.2. All right, so I get, my change in temperature is 184.3. All right, so basically what I need to do, I'm going to say 21.7 times 184.3. All right, so I get 3,000, something like this. I need to get CP by itself. So I need to divide this by 21.7 times 184.3. Okay, and then I need to divide this side by 21.7 times 184.3. Alright, you can already tell that this is, C is going to be the answer just based on this is really going to be a really, really large denominator. But 1855 divided by the answer choice there, and we get answer choice C. Okay? And if not, do the math yourself, but you can see that's what I ended up with on the calculator. Alright, 43 is done. Let's go to 44. Using standard enthalpies of formation. We didn't even talk about this. Round your answer to the 10th place. Alright, so what this is saying here, the energy for, and these aren't difficult to do, it's just we didn't do a lot of these in class. Okay. Your energy for the carbon monoxide, this is going to be negative 110.5. Okay. Your energy for the water, which is a gas, is negative 241.8. Okay. And CO2, negative 393.5. And it tells you that your energy for your H is 0. All right, so we have all those in there. Your formula that you need for this, okay, so it wants you to calculate what is the energy. So this is always in this, it's right here for you. So when you see this, even though we didn't talk about this a lot this year, you're still okay. It's going to be products minus reactants. So I'm going to come over here and I have my products. So my delta H is going to be negative 393.5 minus negative 110.5 plus a negative 241.8. All right, so I'm going to plug this into the calculator. So I get negative 393.5 minus parentheses 110.5. Oh, that's negative, sorry. Negative 110, oops. 110.5 plus my negative 241.8, and you get a negative 41.2. So we're going to come in here. I get negative 41.2. We're going to grid it there, and you guys can do this 41.2. Okay, good. All right. All right, 45, it says the scientist is testing an unknown sample of matter to find its identity. He attempts to distill a uniform sample and finds it to be inseparable. Okay, so distilling means that he's trying to heat it up and separate the liquids, and he finds out that he can't separate that. Next, he begins an experiment with the reactivity of the sample and finds under no circumstances is the sample decomposed into smaller substances. So he can't split it into anything else, right? So what does that mean? Well, first of all, it's not, there's no, it says it's, what does he say here? Okay, so it's uniform, so we know that it can't be a mixture, right? And it can't be a solution because a solution is a mixture, okay? So now we have to see that it's between an element and a compound, and he's saying that he tries to react it, and he tries to decompose it, and it won't break down into anything else. So it has to be an element because elements are the only thing that don't break down into anything else because they're already in their simplest form. All right, given these reactions here, it says find the correct delta H of the reaction. All right, so in this case, this is going to go back again. So if we look at this, we have X here, O2. CO2 is on this reactant side, and over here it's on the product side. So we need to flip this reaction. So we're going to get CO2 plus XO gives me X CO3. So now this equation is gone. We're not worried about that one. Alright, so now we can just add everything because you see that this is on the reactant side, this is on the product side. So those things right there are going to cancel out. Okay, so if we, basically it's like saying that we've got this like an equals line right here, and so we're just bringing everything down. So we have X, we have 1/2 of O2, and we have the carbon dioxide. And then over here we have our reaction. So all we did here was we flipped this. So this is now negative 228.1. Okay? So all we're going to do is add these two numbers together. And when we add those two numbers together, let's see what we get. We get negative 577.7 plus 228.1. And we get negative 349.6. And that is answer choice D. Okay? Alright, we're almost done. And I'm super happy about that. Alright. It says identical amounts of water and potassium bromide are mixed in 4 different ways. In which case will potassium bromide dissolve faster? Alright, so basically we know that things dissolve better in hot water. Okay, and we know that if we break things down into smaller pieces, so we basically make more surface area. So we want hot water, so this answer and this answer choice is out. And then it says we want large potassium bromide crystals or we want it powdered. Well, you guys all know the difference that when you have big chunks of sugar, you have little chunks dissolve better. So our answer choice here is C. 48, it says the quantity of an element in grams equal to the atomic mass of the element. How many moles represent? What? Of an element in grams equal to the atomic mass of an element. the question is crazy. The quantity of an element in grams equal to the atomic mass of the elements represents how many moles of the element. Oh, duh. So they're saying that if you have, like let's say you have 12.01 grams, right? So it's saying that's, and that we're, okay, so a quantity of element in grams is equal to the atomic mass. So if I have 12.01 grams of, this is carbon, right? I know that for every 12.011 grams of carbon, I get 1 mole, right? So they're saying that if this value equals this value, then I have 1 mole, okay? It's just worded weird, but that's basically all it's saying, okay? That's just the molar mass. All right, 49. It says, by the blank definition, an acid is a substance that when dissolved in water increases the concentration of H+, right? A base is a substance when added to water, it increases the OH-, okay? Here's the key. So they give you this Arrhenius, Lewis, Bronsted, and Bohr, okay? Well, you guys know that we've talked about this, and this is what it's telling you. Because this is OH, okay? This is definitely a base, but OH can also be, so there's other bases besides OH, but based on this definition here, we're going to go with Arrhenius. It's the simplest one, okay? All right, which of the following statements about frequency and wavelength are true? All right, so let's look back at our equation here. Here's frequency and here's wavelength, okay? So what this is saying is if frequency increases, wavelength decreases. Which, does that make sense to you? Because if I make this bigger, this value is the same. This value can't change. So if I make this bigger, then I have to make this smaller, okay? Because these are directly proportional to each other. They are related, yeah, so basically because these are directly proportional, as one increases, the other has to decrease. Okay, and they have to be related because we have an equation that shows that they're related, so this is just not possible. Alright, 2 questions left. Here we go. What is the correct name for the following compound? So we know that this is barium, and we know OH, we've hammered this out, so this is going to be hydroxide. Now, here's what's key. Barium is in, if we look on this periodic table, barium is in group 2, and we know that only the guys over in this section here, so in this transition metal, they're the only ones that use Roman numerals. So automatically this answer is wrong, and we know this is wrong because this is a metal, these are non-metals, we do not use di, okay? That's only for covalent compounds. And we know that this is not hydrogen oxide, so your answer choice has to be C. Alright, and this one, last one, select the ion with the largest radius. Alright, so again, when we look at this, remember, as you go down a group, the radius gets bigger. Now, if I lose an electron, I'm going to shrink, okay? If I gain an electron, I'm going to get bigger. So let's look what they give us. They give us Rb, they give us K+. Well, here's Rb. Wait, I lost it. Here's Rb, and this is a positive one, right? And then we have potassium, which is positive. They give us sodium, which is positive, and they give us lithium. So it's kind of irrelevant that these all have positive values because it's basically they've all lost an electron, so they've all gotten smaller. So in this case, it says which one's going to have the largest radius. It's going to be rubidium because it has more electrons. Okay? All right, lots of luck. So here we go. Good luck on your test.